Humans have been trying to get clean for a very long time. It wasn't always easy. Imagine a world without a handy bar of soap next to the sink. It's a rather grimy thought, isn't it? Our ancestors, however, were quite resourceful. They didn't just shrug and accept being perpetually dusty. They looked around and figured things out, often by accident. The earliest known evidence of a soap-like substance dates back to ancient Babylon, around 2800 BC. That's nearly 5,000 years ago. Think about that for a moment. While the pyramids were still a future project, someone, somewhere, was already discovering the basic principles of soap. These early cleaning agents weren't quite the fragrant, colourful bars we know today. They were likely a bit rougher, a bit smellier, and probably used more for cleaning wool and cotton than for a luxurious bath. The Babylonians, clever as they were, reportedly made their soap from animal fats boiled with wood ashes. It sounds a bit like a messy barbecue aftermath, but it worked. The key ingredients were fat and alkali. The fat often came from animals like sheep or oxen, the leftovers from feasts or sacrifices. The alkali, a sort of chemical opposite to an acid, came from those wood ashes. It's a simple recipe, really, but a revolutionary one for its time. Other ancient civilizations also stumbled upon similar concoctions. The Egyptians, renowned for their cleanliness and elaborate bathing rituals, used animal and vegetable oils mixed with alkaline salts. An old legend, perhaps more charming than strictly accurate, tells of Mount Sapo in Rome. Animal sacrifices were supposedly common there. Rain would wash melted animal fat and wood ashes down the mountainside and into the Tiber River. Women washing clothes in the river noticed that their laundry became much cleaner in certain spots. Whether Mount Sapo is a true story or just a good tale, it neatly illustrates the basic ingredients coming together: fat, ash, and water. So the idea of using fat to make something that cleans is not new. It's ancient. It's fundamental. People understood, even without knowing the precise chemistry, that fat could be transformed. It could go from being something greasy and staining to something that quite magically helped remove grease and stains. This early understanding laid the groundwork for centuries of refinement, leading eventually to the sophisticated soap-making processes we have today. It all started with a bit of leftover animal grease and the remnants of a fire, a testament to human ingenuity and our unending quest for cleanliness. So, what is this stuff we call soap? It seems simple enough. You rub it on your hands, it makes bubbles, and dirt disappears. Magic. Well, not quite magic, but certainly some very clever chemistry is at play. Soap is, at its heart, a special kind of salt. Not the salt you sprinkle on your chips, though. This is a salt formed from a fatty acid. Think of it as a tiny, two-faced agent. One end of a soap molecule absolutely loves water. It's hydrophilic, which is just a fancy way of saying water-loving. It wants to grab onto water molecules whenever it can. The other end of the soap molecule, however, is a bit of a water hater. It's hydrophobic, meaning water-fearing, and this is the crucial part, this end absolutely adores oil and grease. It wants to latch onto oily things like the grime on your hands or the food splatters on your dinner plate. So you have these tiny molecules, each with a water-loving head and an oil-loving tail. This dual personality is the secret to soap's cleaning power. It's like having a tiny janitor with one hand for water and the other for dirt. When you wash your hands with soap and water, something rather interesting happens. The oil-loving tails of the soap molecules dive into the grease and dirt on your skin. They surround the tiny particles of grime, forming little spheres called micelles. The oil-loving tails point inwards, sticking to the dirt, while the water-loving heads point outwards, facing the water. These micelles effectively trap the dirt and oil in their centers, suspended in the water. It's a bit like a microscopic prisoner escort. Then, when you rinse your hands, the water washes these micelles away, taking the trapped dirt and grease along for the ride. The bubbles, by the way, are mostly just air-trapped in a thin film of soapy water. While they look fun, they aren't strictly necessary for the cleaning process itself, though they can help lift and carry away dirt. The real work is done by those clever little soap molecules, bridging the gap between the oily dirt you want to remove and the water you're using to wash it away. It's an elegant solution to a mucky problem. The process of making soap has a rather grand name, saponification. It sounds complicated, perhaps like something requiring a laboratory full of bubbling beakers and scientists in white coats. But at its core, saponification is a fairly straightforward chemical reaction. It's the process that turns fats or oils into soap. As we touched upon with our Babylonian friends, you need two main ingredients, a fat or oil and a strong alkali. The alkali is typically sodium hydroxide, also known as lye or caustic soda, for making hard bar soap. For liquid soap, potassium hydroxide is often used. Let's talk about fats first. Fats and oils are made up of molecules called triglycerides. Imagine a tiny structure with a glycerol backbone and 3 fatty acids attached to it. Like 3 arms sticking out, these fatty acids are long chains of carbon and hydrogen atoms. Different fats and oils have different types of fatty acids, which is why olive oil is liquid at room temperature and beef tallow is solid. These differences also affect the kind of soap they produce. Some make a hard, long-lasting bar, while others create a softer, more moisturizing lather. Now enter the alkali hour lye. When you mix the fat or oil with the lye solution, the saponification reaction begins. The strong alkali works to break apart the triglyceride molecules. It's a bit like a chemical demolition crew. The lye essentially splits the fatty acids away from their glycerol backbone. Once these fatty acids are free, they react with the sodium from the lye. This reaction forms the salt of the fatty acid, and that, my friends, is soap. The glycerol that was once the backbone of the fat molecule is also released as a byproduct. Glycerol, as it happens, is a rather useful substance itself. It's a humectant, which means it attracts and retains moisture. In many commercial soap-making processes, the glycerol is removed and sold separately for use in lotions, cosmetics, and even food products. However, in traditional or homemade soap, the glycerol is often left in. This results in a more moisturizing bar of soap, which can be quite lovely for your skin. So, saponification is not just about making soap, it's about transforming fat into 2 useful things, a cleaning agent and a moisturizer. When it comes to making soap, not just any old fat will do. Well, technically, most fats and oils can be saponified, but the type of fat used has a huge impact on the final soap product. Think of it like baking a cake. You can use different types of flour or sugar, and each will change the texture and taste of your cake. Similarly, different fats will give you different soap qualities. Some fats create a hard, durable bar that lasts for ages. Others produce a soap with a rich, creamy lather. Some are incredibly cleansing, while others are more gentle and moisturizing. Vegetable oils are very popular in modern soap making. Olive oil, for instance, makes a very gentle, mild soap known as Castile soap. It's great for sensitive skin but might not produce a huge amount of fluffy lather on its own. Coconut oil, on the other hand, is a lather champion. It creates big, bubbly suds and a very hard, cleansing bar. However, too much coconut oil can be drying for some skin types. Palm oil is another common ingredient, contributing to a hard bar with a stable lather, though its use has become controversial due to environmental concerns surrounding its production. Then there are the animal fats, the original soap-making ingredients. Lard, which is rendered pig fat, and tallow, which is rendered beef or sheep fat, have been used for centuries. These fats tend to produce very hard, white, long-lasting bars of soap. They also create a creamy, stable lather that many people find quite luxurious. Historically, these were readily available and inexpensive, making them practical choices. The fatty acid profiles of animal fats are different from most vegetable oils, leading to these particular characteristics in the soap. For example, stearic acid, common in tallow, contributes to hardness. So soap makers often use a blend of different fats and oils to achieve the perfect balance of properties. They might combine coconut oil for its fantastic lather, olive oil for its gentleness, and perhaps a bit of shea butter or cocoa butter for extra moisturizing qualities. It's a bit like being a chef, carefully selecting and combining ingredients to create a desired outcome. The choice of fat is fundamental. It dictates the soap's hardness, its lathering ability, its cleansing power, and how it feels on your skin. It's all in the fat. Section 5. The human element, how much fat do we carry? Now this brings us to a rather curious and perhaps slightly unsettling question. What about human fat? If animal fats like tallow and lard can make soap, could human fat do the same? From a purely chemical standpoint, the answer is yes. Human fat, like other animal fats, is composed of triglycerides. These triglycerides can indeed undergo saponification when mixed with a strong alkali like lye. The basic chemistry is the same. Our bodies are in part walking storehouses of potential soap-making material. It's a strange thought, isn't it? The amount of fat a human body contains can vary enormously, of course. It depends on factors like age, sex, genetics, diet, and activity level. A very lean athlete might have a body fat percentage in the single digits, say 6 to 13% for men, or 14 to 20% for women. An average healthy adult might fall into the range of 18 to 24% for men and 25 to 31% for women. However, individuals can have much higher body fat percentages, sometimes exceeding 40% or even 50% in cases of significant obesity. These percentages represent the proportion of total body weight that is fat. Let's try to put some numbers on this. Consider an average adult male weighing, say, 80 kilograms, which is about 176 pounds. If he has a body fat percentage of 20%, then he is carrying around 16 kilograms of fat. That's roughly 35 pounds of fat. For an average adult female weighing 70 kilograms, or about 154 pounds, with a body fat percentage of 30%, she would have 21 kilograms of fat, which is about 46 pounds. These are just averages, of course, and individual amounts can be significantly higher or lower. So the human body, depending on the individual, can store a substantial quantity of fat. This fat is primarily stored in adipose tissue, which is found under the skin, known as subcutaneous fat, and around internal organs, known as visceral fat. While its primary biological roles are energy storage, insulation, and cushioning, its chemical composition means it shares the fundamental properties of other animal fats used in soap making. The idea is certainly a bit macabre, but the chemical potential is undeniably there. We are, in a way, carrying our own soap-making kits, albeit in a rather unconventional form. Section 6, doing the math from body fat to soap bars. Right, let's get down to the nitty-gritty. If we were to, hypothetically speaking, use human fat to make soap, how many bars could one person actually produce? This is where we need to do a little bit of soap-making arithmetic. First, we need to understand how much fat is required to make a certain amount of soap. This isn't a one-to-one conversion, as the lye and water also contribute to the final weight of the soap, but the amount of fat is the primary determining factor for the yield. Different fats also have different saponification values, meaning they require slightly different amounts of lye. For simplicity, let's assume human fat behaves similarly to other animal fats like lard or tallow in terms of soap yield. A general rule of thumb in soap making is that you get roughly 1.3 to 1.5 times the weight of the fats in cured soap. This accounts for the lye and the water that remains in the final bar. So, if you start with 1 kilogram of fat, you might end up with about 1.3 to 1.5 kilograms of soap. Let's use an average of 1.4 for our calculations. This means 1 kilogram of fat yields approximately 1.4 kilograms of soap. Now, how big is a standard bar of soap? They vary, of course, but a typical commercial bar of bath soap might weigh around 100 grams to 125 grams, about 3.5 to 4.4 ounces. Let's take an average of 115 grams per bar for our calculation. So if 1 kilogram, which is 1,000 grams of fat, yields 1.4 kilograms or 1,400 grams of soap, how many 115 gram bars is that? We divide the total soap yield by the weight of 1 bar, 1,400 grams, divided by 115 grams per bar, is approximately 12.17 bars of soap per kilogram of fat. Let's round that down to about 12 bars of soap per kilogram of rendered fat, to be a bit conservative. So if an average person has, say, 16 kilograms of body fat, as in our earlier example, and if each kilogram of that fat could yield about 12 bars of soap, then 16 kilograms of fat times 12 bars per kilogram equals 192 bars of soap. That's a lot of soap. To make just 7 bars of soap, you wouldn't need an entire person's worth of fat, not by a long shot. 7 bars of soap at 115 grams each would weigh 7 times 115 grams, which is 805 grams of soap. Working backwards, if 1.4 kilograms of soap comes from 1 kilogram of fat, then 0.805 kilograms of soap would require about 0.805 divided by 1.4, which is approximately 0.575 kilograms of fat. That's just over half a kilogram, or about 1.27 pounds of fat to make 7 bars of soap. Section 7. Echoes from the past. Whispers of human fat soap. The idea of using human remains for practical purposes is not entirely unheard of in the darker corners of history, though it's often shrouded in rumor and revulsion. When we talk specifically about soap made from human fat, concrete, widespread historical evidence is rather scarce and often veers into the realm of folklore or wartime atrocities. It's not something that ancient civilizations or even more recent societies typically documented with pride, for understandable reasons. The reverence for the dead in most cultures would generally preclude such a practice on any industrial or accepted scale. However, there are unsettling whispers and accusations. During World War II, horrific rumors circulated that the Nazis were mass-producing soap from the bodies of their victims in concentration camps. The infamous RAF soap, Reichsstelle für Industrielle Fettversorgung, or Reich Center for Industrial Fat Provisioning, was rumored to contain human fat, with some bars allegedly stamped with initials that were misinterpreted. While investigations after the war largely debunked the idea of systematic industrial-scale production of soap from human fat for widespread use, the psychological impact of these rumors was devastating and highlighted the depths of inhumanity people feared. Small, isolated experiments might have occurred, but not mass production. Beyond these grim wartime accusations, the general rendering of fats from various sources has a long history. In times of extreme scarcity or in specific isolated contexts, it's conceivable that human fat might have been used, but it would have been an act of desperation or profound disrespect, not a standard practice. Medical schools, for instance, in the past would have dealt with cadavers, and the disposal of human remains would have involved various processes. However, converting this to soap for general use is not a documented part of that history. The primary fats for soap remained animal tallows, lard, and vegetable oils. It's important to distinguish between the chemical possibility and historical practice. Yes, human fat can be saponified, but did people routinely do it? The evidence suggests no, not in any organized or accepted way. The tales that do exist are often linked to the most horrific periods of human history or to macabre fiction. The visceral unease the idea provokes is strong, and for good reason. While our ancestors were resourceful with animal products, the line at using human remains for such utilitarian purposes like soap seems to have been, for the most part, respected, if not always, for ethical reasons, then perhaps for practical ones or deep-seated cultural taboos. Section 8. Modern Science and Soapy Morals. In our modern age, with advanced chemical knowledge, we understand the process of saponification better than ever. We can analyze fats with incredible precision and tailor soap recipes to achieve very specific qualities. The science is clear. Human fat, being a triglyceride-based substance, is perfectly capable of being turned into soap. If one could ethically and practically obtain human fat, render it and then combine it with the correct amount of lye, the chemical reaction would proceed just as it does with tallow or olive oil. The resulting product would be, scientifically speaking, soap. However, the ethically and practically obtaining part is, of course, the enormous, unshakable barrier. In contemporary society, the idea of using human body fat for such a purpose is almost universally abhorrent. Our ethical frameworks, legal systems, and general sense of human dignity place immense value on bodily integrity, both in life and in death. The thought of harvesting fat from deceased individuals for consumer products like soap falls far outside any acceptable moral boundary. Even fat removed during medical procedures like liposuction is typically treated as medical waste and disposed of accordingly, not repurposed for cosmetics or cleaning agents. There have been, it must be said, occasional provocative art projects or conceptual pieces that have played with this idea, often to make a statement about consumerism, mortality, or the commodification of the body. These instances are designed to shock and provoke thought rather than to suggest a viable or desirable product. They operate in the realm of challenging taboos, not in the realm of practical manufacturing. The overwhelming societal consensus remains firmly against such practices. The yuck factor is immense, and rightly so, intertwined with deep respect for the human form. So while science confirms the possibility, ethics and societal norms firmly forbid the practice. We have plenty of other, readily available, ethically sourced fats and oils to create all the soap we could ever need. From plant-based oils like coconut, olive and palm, sustainably sourced, one hopes, to traditional animal fats obtained as byproducts of the meat industry, there's no shortage of suitable raw materials. The journey of soap from ancient discovery to modern chemistry is fascinating, but the chapter on using human fat is one that remains, and should remain, largely unwritten in the book of practical application. Section 9. The body's unseen potential, more than just us. Reflecting on the rather unusual question of whether our bodies can make 7 bars of soap, or indeed many more, leads to a broader contemplation. The human body is an astonishingly complex and resourceful biological machine. We often think of it in terms of its living functions: movement, thought, feeling, growth. But even in its basic chemical makeup, it holds surprising potentials, some of which, like soap making, are more curiosities of chemistry than practical applications. It reminds us that we are, in a fundamental sense, composed of the same building blocks as the world around us. The fact that human fat is chemically similar enough to animal fat to be saponifiable is a testament to the shared biochemistry of life. Triglycerides are a common way for living organisms to store energy. This underlying commonality is a recurring theme in biology. While the ethical considerations are paramount and rightly prevent such uses, the scientific possibility itself highlights how interconnected material cycles can be. It's a stark, perhaps even uncomfortable reminder of our physical nature. We are matter, and that matter can be transformed. Beyond the slightly macabre example of soap, our bodies have other hidden material values, historically speaking, though again often in contexts we now find ethically challenging. Anatomical specimens were once highly prized. Hair has long been used for various purposes, from wigs to violin bows. Even bones have been ground for fertilizer in desperate times, though this is far removed from any sense of personal utility. These examples, like the soap question, push us to consider the boundaries of how we view the human form and its constituent parts after life. Ultimately, the journey into the science of soap and the peculiar question of human fat serves as an engaging, if slightly unsettling, way to explore chemistry, history and ethics. It shows that even mundane household items have fascinating stories behind them. And it underscores that the human body, this vessel we inhabit, is full of surprising complexities and, from a purely detached chemical perspective, a remarkable assembly of convertible materials. The real value, of course, lies not in its potential for soap, but in the life, consciousness and experiences it enables. 7 bars of soap, chemically plausible, ethically unthinkable, and a fascinating detour into the science of ourselves.